I am going to explain about total probability or total probability concept. If you want to get my future videos, subscribe my channel. If A is an event in a sample space S, then the total probability of A can be defined as sigma n equal to 1 to n probability of A multiplied with probability of A by Bn. I will tell you here. This is an total probability theorem. I will explain. P of A, if A is an event and B1, B2, B3 are up to Bn, B2, B3 up to Bn are the events, then the probability of A, total probability of A is defined as conditional probability, probability of A by B into probability of B. So I will explain here. So it is an sample space S. S is a sample space. It is having the events. It is having the events A, B1, it is an event. B2, it is an event. B3, it is an event. So like this, it is having till Bn. Bn events are there. And here also it is B4. So here internally one more event is there, that is A. A is also one of the event. So then probability of this A can be defined as probability of A is equal sigma I equal 1 to n probability of A by Bn multiplied with probability of Bn. So I will give the proof, and he is saying that B1, B2, B3, B4 up to Bn are the mutually exclusive events. So means there is no common probability. So coming to the proof, we can say this. So he is saying that B1 union B2 union B3 all union, it is having union Bn is equal yes, sample space S. So if it is very negligible, if A is so, and also can be written as, because all are mutually exclusive, there is no common elements between B1 and B2. So that's why S can be also written as S is equal union of n equal 1 to n Bn. So we can write it like this because S, and we can take it as, if we take A intersection S, we can write it as A intersection S, can be written as A only, because if A is having 1 2 elements and B is having 1 2 3 4 5 6 7, for example, so then what is an A? A intersection S, total S is having till 1 to n. So then whatever may be the A elements, the same thing will get it. So that's why we can write it as A intersection S can be written as A. So probability of A can be, if you take probability both side, probability of A intersection S. So therefore probability of A intersection S means, we can say this from this equation, union of n equal to 1 to n Bn. 1 to n Bn. So here we can take it outside, that is union, and I will write it as union can be, that is n equal 1 to n sigma probability of A intersection Bn. If you take it outside, union or sigma. So this is P of A, P of A. Now we can say this is A intersection Bn. So according to conditional probability, we can write it as conditional probability for A and B. Conditional probability can be written as probability to get A, probability to get A, probability to get A if already B is happened is equal common probability P of A intersection B divided by already happened probability. So already occurred, that is B. So from this we can write it as cross multiplication P of A intersection B. P of A intersection B is equal P of A by B, P of A by B multiplied with P of B, P of B. So substitute this equation N3, N3. Second equation N3. So can be written as P of sigma N equal 1 to N probability of A by B or A by Bn in the place of B, Bn multiplied with P of Bn. P of A is equal P of A is equal P of A by Bn multiplied with P of Bn. So this is the total probability. This is the total probability for A. If S is a sample space having the elements B1, B2, Bn and internally it is one more event is there, that is A, then probability of that event can be written by using A intersection S. So by using this we can write it. We can get the probability of A. So that is equal to A by Bn into probability of Bn. I will tell one example for this total probability theorem. So here you can see this one box, one sample space is having two boxes. Here you can see this two boxes. Here one sample space. So here it is the box one is having two white balls. I am assuming two white balls and three black balls, for example. And box two is having three white balls, three white, and four black balls are there, four black balls. So then he is asking what is the probability? What is the probability to get white ball? Probability to get white ball. So in that case, we need to go for total probability theorem. We can say this. So probability to get white ball. If it is single one, so we can directly calculate two white balls, for example, three black balls are there. So in that case, what is the probability to get white ball? What is the probability to get white ball if already black ball is drawn? So means we can write it. We can get this. What is the probability to get white ball? There are two white balls are there. If already one black ball is drawn means there are only two black balls are there. So again 2 plus 2 only 4 balls total balls are there. So we can calculate like this white ball probability if it is single box. So coming to the two boxes are there, in that case we need to go for white ball probability of box 1 and white ball probability of box 2. So two boxes probabilities we need to find. So for that, using total probability theorem, probability of A is equal probability of A by B1 box 1, probability of box 1 plus probability of A by B2 box 2 if we are selected, probability of box 2. If one more box is there, you will get it one more, because the total probability P of A is equal sigma I is equal 1 to n P of A by Bn multiplied with P of Bn, P of Bn. So here we can get it probability to get white ball if box 1 is selected, B1. Probability to get white ball if box 1 is selected, what is the probability? Two favors are there. Out of 2 plus 3, total number of favorable outcomes are 5. And probability to get box 1. B1 means probability to get box 1, 1 by 2, because two boxes are there. So box 1 probability, that is 1 by 2. Probability to get box 2 is also 1 by 2. 1 by 2. So if three boxes are there, that is favorable outcomes by total number of outcomes. So this is the favorable is only 1, 1 by 2. Here also box 2 is only favor is 1, 1 total out of 2 boxes. So therefore here we can say this 2 by 5. Probability to get box 1 is 1 by 2 plus probability to get white ball from box 2. So 3 favors are there to select white ball. 3 favors by total number of balls are, that is 7 balls, multiplied with B2, probability to select box 2, 1 by 2. So this is the probability 2 by 10 plus 3 by 14. 3 by 14. So this is the probability. By using total probability we can calculate. So if multiple number of boxes are there, multiple number of events are there, in this case we are going for total probability. If you have any doubts or suggestions, send to me. Thank you.